going to be how the integration is going to be in the future. And now it's becoming more like your the nervous system of a modern enterprise. That's where it is going to be.
And LLM cannot do that. LLM can only deal with the text and prediction based on the text.
It gives me an image as an output. So is it LLM or what is that?
So out of that prompt, it should understand what is the intent of the user, what type of image they are looking, what is the background that we are expecting. You can see it as a helping hand.
Hello everyone. Welcome to the 5th podcast in the series. I have Mr. Praveen P.R. Praveen is leading our architecture team at NJC. Hello, Praveen. Welcome to the podcast.
Hi, Bejoy. Thank you. How are you?
I'm very good. Thank you. And how are you? How are things going?
I'm good. So how was your experience in this year's Dreamforce? You attended it, right?
Yeah, I just came back from Dreamforce a couple of weeks back, and it's been amazing, right? So this is my, I think, fourth Dreamforce, and this time it was more around Agentic Enterprise. And there were a lot of announcement regarding Agentic Enterprise from different Salesforce clouds, and of course from MuleSoft we have got
Agent Fabric.
Agent Fabric. I think a lot of the things which we are going to discuss today probably will relate to Agent Fabric capability. So let's discuss that later on. So about, I think like I mentioned, this is the 5th podcast. Thank you for coming for first of all. We had previous podcast discussing about enablement, training, platform setup, different deployment options. We had Sandeep, Shiva on the podcast. Now today I thought we will focus more on how the integration is going to be in the future, right? So now integration has been evolved a lot in the last many years, and with this AI buzzwords like AI agents, MCP, and all of that, I think that's going to have a lot of impact in the integration space. And since you come from integration background, you have got massive, maybe 2 decades of experience in integration. So I'd like to hear more from you about how it's going to be and how integration is going to shape on its own, and what's the impact of that in the integration platforms like MuleSoft and the platforms out there. So happy to take, or I would like to hear what you think. So let's start discussing about some of the fundamental topics when it comes into AI before going into deep into the future of integration, right? Now from an integration perspective, we know integration has been always around. Like in the past, it was mostly like a plumbing exercise, right? Plumbing your back office applications, and now it's becoming more like your the nervous system of a modern enterprise. That's where it is going to be. So it's more important, more strategic integration. So yeah, let's start talking about some of the fundamental topics. Like machine learning, LLMs. So I hear a lot of my lot of people I speak to, I see them contradicting the basic concepts of LLM versus ML. So maybe we'll just start with that. So how do you explain to the audience, like, what's the difference in playing?
So both are same in one way because both are looking for patterns. But the difference is that the LLM looks for patterns in the words and ML looks for patterns in the numbers. Right? So LLM is trained with large amount of data that are text in paragraphs. So it understands the words, it understands the sentences, so it can generate things. So basically it reads the patterns and knows how to apply it. Now that's the same thing if you use numbers, and that's where ML comes in. And LLM cannot do that. LLM can only deal with the text and prediction based on the text. But ML is something that looks at the data, the tabular data that you have provided, and then identifies the patterns. So pattern means in the data you have to say that this is the data that you're looking for, the output that you're looking for. For example, let's say sales prediction data. So you have a lot of historic data, and your intention is to find out what will be the sales data for the next month. So your historic data, you provide it to an ML and tell the ML that the sales column is what I'm looking for. And I think these are the input features that I think is affecting the prediction. So it will use that your input to find out a pattern, and then it will create a model. And then using that model, you can predict. You can start using and predicting the sales or whatever it is.
Okay. Yeah, I think that's very useful, right? So understand the difference. So to summarize what you said, so LLM is more like reasoning on a text input which you give, works with text, and whereas if you look at ML, it more about the numbers. You understands and takes numbers as input, and then look at it, automatically understand the pattern and then predict something. Now, just to clarify another thing, right? Because I was curious. Now, if I ask ChatGPT, give me you create an image based on this, right? So on a natural language, it gives me an image as an output. So is it LLM or what is that?
Right. So the image generation is done by another type of model. So there are diffusion models specifically for creating images.
Right. So that's not LLM.
That's not LLM. But still, in this use case, whatever you've told, we need LLM because the user has provided a prompt. So out of that prompt, it should understand what is the intent of the user, what type of image they are looking, what is the background that we are expecting. And the LLM uses that to identify the intent. It gives it to a diffusion model, and the diffusion model creates an image. So it's model to model. It's not completely LLM.
Oh, okay. So that means it's multi-model scenario. So it uses LLM and diffusion model behind the scenes.
Yes.
So maybe if you go further, like OpenAI has got multiple models. ChatGPT is the LLM model, and then maybe a diffusion model also is there for.
They will have a type of diffusion model.
Okay, right. And they combine both together, and it works on that basis. Okay, that's very clear. Okay, so that's your LLM, and that's ML. Now, in terms of the other concepts which we see often is MCP, or maybe even before
agents.
There is agents, or maybe even before there is a RAG.
RAG.
So let's see what RAG is, and then we'll go to MCP and agents.
RAG is Retrieval-Augmented Generation, which is technically a bit difficult to understand. But let me give an example. So LLM, as we know, it requires large amount of data to train. So it is already pre-trained, right? So let's say we have an LLM which is trained with the data till 2024. And then you are asking that LLM a question about who scored the maximum runs in this year's IPL. But the LLM will not be able to answer because this year's data is not available with the LLM. Right. So using RAG, you have to provide the current year's data. And then the other things like LLM is very smart in understanding the data that you have provided. It knows what is the question, and then it will give the right answer because now it has the real data, the context data that is required. So that is known as RAG.
Okay, so you provide or you augment your LLM with additional data, and then you retrieve the
more accurate
or updated information based on the data you provided. Okay.
Not hallucinated.
Okay, right. Otherwise, if you don't specify the timelines, you probably will get a outdated. Right. Okay, so that's right.
No, but I think LLM is smart enough to tell that I don't know the current year's data.
Okay, so it'll tell you it more proactively, but if you
will not get the answer.
Okay, right. That's clear now. Now the next topic is MCP, right? Model Context Protocol. And then we have got to agent, and maybe agent. Right. So what's the significance of MCP now? Because we hear a lot about MCP these days.
So that's related to one of the shortcomings of LLM. LLM can understand your query, It can give a generic answer. It can even suggest the actions that you need to do, but it cannot execute the action. For example, it can search for trains, but it cannot book because it has to actually call an API to book it, and it has to connect to a financial payment system to do the payment for you. So MCP is for giving these opportunities, these features to LLM. So you specify kind of tools which are actions that an LLM can perform, and there are other primitives like resources where you can provide your database schema, the full schema you can provide. So if you provide the full schema, then the LLM knows the table structure, the relationship. Now it can also answer all the queries that you ask. If you want to join a couple of tables and get the data, then since the schema is there, it can provide you the exact query. Now you just have to execute, and even to execute, there are tools available. So if you provide an API that will get any SQL statement and execute it and expose it as a tool, then you have everything.
Right. Okay. So that's now even more clear. So we have got MCPs. That's to help LLMs perform some actions.
Yeah.
Right. So that means every SaaS applications
Yeah.
will eventually expose MCP
Yeah.
capability so that LLMs will be able to communicate to SaaS directly.
Yeah. So if you are thinking about an agentic use case where people are building agents, then they need MCP or other agents to execute these actions. So
Right.
MCP is important there.
So since you mentioned about agents,
Agents and agent to agent communication, I already mentioned.
Yeah. So how do like there's a lot of agents out there in the market now.
Yep.
Right. So there are agents from SaaS providers. There are agents you custom build using agentic framework.
Yeah.
So we have got different agentic framework. Salesforce has got Agentforce, and there are other platforms. Right. So how this will evolve in the future? This agents and agentic enterprise, and what do you think about it?
Yeah. So shall we start with the agents before going into?
Yeah, absolutely.
Right. So agent is very closely related with LLM because behind the scene it is LLM. It uses the reasoning capability of LLM. So by reasoning, it can identify some actions that it has to take for the user's query. So the user has set a goal, and to reach that goal with the context information, the agent will identify that, okay, I have to have these many actions in this particular order. So that action and other things it already knows because we have MCPs, we have capabilities that was published to that agent. And if the agent has a communication with that MCP servers, and it knows that there are some features in that MCP. So whether that features are related to this goal, the agent will already understand and identify all the actions required, and then it will autonomously execute these actions. So that's what an agent does. And now if you have multiple agents and if you need to talk between those agents, you have A2A.
Right.
So agent will automatically communicate with each other. They will share their capabilities, and they will ask questions, and this agent will respond. So an agent will be focused on one action, but another agent can be created to use those actions, multiple features of multiple agents, and to perform a workflow.
Right. Okay. So then that means so in the microservices world, we had domain-driven design. So we had the agents for not agents. We have services or APIs or microservices for each domain. Multiple microservices for a domain, and we group them based on some domains, right? So when we design agents, can we follow same pattern, or do you suggest anything else from an architecture perspective?
Yeah, it's still an evolving subject, but I would focus an agent to focus on, just like taking the cues from the microservice, an agent should focus on one of the tasks,
Right.
one functionally distinguished task. And there can be brokers. That's again another agent, but you can tell it as broker that will connect a different agent and execute a workflow.
So we discussed about all these different like fundamental topics, right? Now let's move on to the evolution of integration, right? So we know traditionally there were different ways of integration, and it's evolved, and it's going to be change in the future as well. So maybe how it was and how it will be in the future, maybe you want to.
Yeah, so integration started with point-to-point integration. So we had database scripts to call the data, and then it evolved into SOA, ESB came into the picture, and then for better manageability and extensibility, we moved to API-led architecture, and then microservices came in. So and the next evolution is to incorporate all the other things that we have added, like MCP agents and 8-way and everything. So integration was about connecting different applications, and now the integration will be connecting different experiences instantly, securely, and intelligently.
Right. Okay. So it'll augment with all these AI capabilities,
Correct.
which we discussed, right?
Yeah. So all the platforms should also be changed or updated to use all these capabilities.
Okay, I think that's an important aspect, right? So all the iPaaS platforms,
Correct,
including
yeah.
MuleSoft and other platforms out there, will need to be evolved to support the AI capabilities out there.
Correct. Yeah.
Right.
So
Okay.
that's where probably Agent Fabric also comes.
Yeah, absolutely. So Agent Fabric has got all these different features, which lays the foundation of AI augmented integration.
Yeah.
Okay, that's great. So now architecturally, so now we discussed about evolution. We discussed about all these fundamental, like the definitions of these topics or terminologies. Now, in terms of architecture, we discuss about API-led architecture or a composable architecture or microservices. Now, with this AI augmented architecture, how does it look like? Will it be? We know this in API-led or service-oriented architecture. We had different types of services or different categories of APIs. We classify them into differently based on what they do.
Yeah.
Will we still use those API-led architecture, or when AI components comes in play, will it change? How will be the impact?
Yeah. So I think APIs will be there, because ultimately, if you want to perform any actions, you need to have APIs. But agents will also come, and one problem that I see is that, for example, you will not trust a robot to babysit your child, right? Because it's very, very, very close to our heart. So that's the same thing. So if you, of course, agent can autonomously do a lot of tasks, but your integrations are deterministic in nature. So you want to ensure that that sequence, that characteristics is applied everywhere. So I don't think a fully autonomous agent enterprises will choose. So that's where the brokers comes in. So there should be some guardrails that we need to apply and tell the agent, like, this is what you need to do. If something fails, this should be done, something like that. So so an agent or a broker to orchestrate all these things is a necessary one.
Okay, yeah, I think that's an important aspect, right? So especially with the integration, deterministic nature of integration is important. Maybe I don't know whether that's an interesting topic, because when you create a deterministic nature of integration, the autonomous capability or self-learning capability and adapting to that environment, we probably will stop the agents to do that, right? If you put a lot of determinism in this entire design. So I think that we should have a right balance of deterministic integration, but at the same time, we should give them some capabilities to learn from what's going on and then adapt to this new environment. So that's important. So you mentioned about guardrails. So when AI agents are built, so you mentioned about AI agents communicating to APIs directly or maybe to MCPs. So all that will happen, and you put guardrails. You put A2A brokers. You mentioned about to have that deterministic nature in it. Is there anything else on top of it? Like, say, for example, so in the API world, we had security policies applied on top of API. So in agents, should we do something similar, or is there anything?
Definitely, yeah. So there are some built-in security available in this protocol, for example, MCP. But then you have to have your own policies as well, right? So that's where Agent Fabric has one of the core design principle that they are giving is the govern part.
Yeah.
Right. So all the policies that you have, so this is a bit technical on the agent fabric part itself. So you are deploying everything to a private space, and the interactions are managed through Flex gateways. So the policies that you have in the Flex gateway can be applied on that.
Okay, so you apply policies on agents, and then you make sure that you're securing your agents, and so that's how you achieve governance. Okay, so then all the good things about microservices, right? So your observability. So you mentioned about governance, then the visualization capability. So all that will still be applicable in the agentic era as well. Yeah.
Because since everything is autonomously, you should also understand, okay, what is my agent doing? Is my agent calling this agent or that agent? So as your network grows, you add more agents, you add more MCP. There should be a platform where you need to visualize for a particular use case from this agent or from this broker what is happening, how many agents we are communicating, right? So visualization should be a part of any platform, and Agent Fabric has that, the visualization.
Great. And so one is visualization, then of course the observability. So you need to be able to trace the request end to end. Okay, that's good. Monitoring, all that will come in play. Right. So
governance also we talked about.
Governing all these agents and other assets which you created. So it's similar to the composable or API-led architecture, but the only difference is you add agents into the solution. You add a MCP, and they call each other or call your APIs and all of that, and then the agent will become the channel, one of the consumer.
You can say that instead of process API, you introduce an agent.
Okay. Right. If you relate that into your MuleSoft world.
API-led.
Okay. That's good. So that covers the architecture part. We also have to discuss maybe one of the question I had was, of course, we use platform iPaaS kind of platforms mostly for transactional use cases. And let's say you call one agent wants to execute a particular, let's say, account creation you are doing via agent that integrates with 5 different systems. And if the last system integration fails, you probably will have to roll back, or you will have to roll back all other steps which you did in the past, did before. So kind of a design pattern, like a saga pattern, or you implement using rollback mechanisms. So that type of steps, right? That's what the deterministic nature of your integration.
Yeah.
And if you use agents, where do you implement that? And because some of these will be done by agents, some could be by MCP. So where do you keep all of that from an architecture perspective?
Yeah, so that's kind of an orchestration, right? So you have building blocks. It could be MCP, it could be agents. So you create an agent, which we can call it as a broker. So there you specify all the rules.
Right.
So that's, I think we touched based on that. So you are limiting the autonomous nature of an agent because you have now rules. So this is what it should do.
Right. Okay, so that's where the right balance.
Yeah.
Okay, so you need to apply certain scenarios. You should have a strict rule. Certain other
Yeah.
places you give your agent a bit more flexibility so that it
Yeah.
could be adapting to the situation. Yeah. Okay, that's great. And maybe towards the end, especially from an integration perspective, we discussed about all these different things, right? The architecture, the evolution, the different terminologies in this new world, and then when it comes into delivery of projects, especially integration projects, we in the past we used to build APIs, we deploy them, we build microservices. It used to take not weeks but months to deliver maybe a project, right? In this new AI world, how that the delivery model, because we still have roles like architects, we have developers. What is going to happen to these roles? Will it stay same? And the overall timeline of the integration projects, will it be more? Will it be less? Where is it going?
Yeah, I think if you think logically, AI is helping you, right? So why can't it help to code? Why can't it help to do many of the repetitive tasks that you're doing? So we can create agents like your design agent that will create diagrams, sequence diagrams, right? And you can have a development agent that will generate flows from your input, generate ML codes based on your technology. You have deployment agent to deploy your applications, your monitoring agent to monitor everything. So these agents will come, it's already there. So this is definitely going to reduce the overall timeline. So earlier manually everything was done in months, now you can reduce the time, right? So yeah, so that's basically what I think. And for the human part, um, you can see it as a helping hand. So architect will have a agent to do to help him. So drawing diagrams is a time consuming task, right? So if you still have to provide the idea to the agent, because you are creating a design. You provide that design in prompt to your agent, and the agent is simply generating a diagram.
Right.
So everything will the total amount of time that is required by you will reduce. You, you can be an architect, you can be a developer. If it's a developer, the design agent or the development agent can generate the flow. So maybe it is 80% correct. You only have to do the rest 20%.
Okay, so if I understand it correctly, then it it reduces the timeline drastically.
Yeah.
And you will still have developers and you will still have architects. Probably architect will play more of a strategic role, and the design agents.
Yeah.
So now MuleSoft has got this vibe, and then build dev agent, and NJC has partnered with an organization called Interlog, where we exclusively got the rights to use the agents provided by Interlog. So yeah, so there are agents out there in the market which will certainly help us delivering projects faster, of course, and also help the humans as well, right? So, okay. So that means we will need. So you mentioned about a 20%, 80-20 rule, right? So a lot of the things can be done by agents. So you will see specialists. So everyone needs to be specialist, and then the maintain or the normal task can be done by agents. Is what you think?
Yeah, that's what I think.
Okay, great. So now I think we pretty much covered most of the topics. Maybe the last, maybe just before we conclude, right? From an enterprise perspective, the business outcomes and how AI is going to impact the business outcomes of enterprise. So what's in for enterprises?
Yeah. So the last topic that we discussed is the different agents that will help your architects, your developers. So and the direct outcome is that it will decrease your development time, right? So your time to market will increase and your total ownership cost will reduce. So I think that's what the enterprise or the business impact is going to be. It will help you to time to market
Okay.
and
Reduce
the cost.
Yeah, reduce the cost and reduce the time to market as
yeah.
well, right? Not increase.
Yeah.
Okay, so time to market reduces. TCO, from an integration TCO perspective, overall TCO will be less, and you achieve faster business outcomes. You don't need to wait for maybe months and years to get something. So that's really important for businesses, right? So that's great. So enterprise, of course, is getting a lot out of AI. And now to conclude all of these topics, right? If I summarize once again all the topics which we discussed, we started with the definition of certain terminologies like ML versus LLM, then agent, MCP, A2A, brokers, and all of that. Rank, of course, that was quite important. Then we looked at the vision or the evolution of integration from point to point to integrations, then to the like agentic augmented AI based integration. We also have seen the architecture styles, the modern architecture, how it's going to be impact of AI in business or enterprise.
And people
And yeah, the human part, right? How AI is going to affect the overall delivery of the projects and the people as well. So if I ask you to summarize everything in one statement, right, a closing statement, how it would be?
Not in one statement.
Maybe multiple statements.
Multiple statements, maybe. Integrations currently is between different systems. So we create APIs and do that. But integration will evolve to include AI and intelligence as well. Yeah. So I would say that the future is integration is not just moving data. It is going to move intelligence.
Okay, I think that's a nice statement. Not moving data, but move intelligence. Yeah, I think that's a good way to close our conversation. Anyway, thank you so much, Praveen, for joining this podcast.
Yep.
Probably we'll have a lot of sessions like this in the future. And yeah, thank you. And
Thank you for your time as well.
Okay, thank you. Nice conversation. Cheers.